In this video, we're going to continue working with rational expressions, and we're going to work on adding and subtracting today. So something to remember, anytime I add or subtract fractions, I have to have a common denominator. When I do, the denominator stays the same, and I add the numerators, okay? So once you have the common denominator, this does not become 14, it stays at 7, okay? If we don't have a common denominator, so this is just some review of fractions, and then I'll talk about how to do it when we have variables in our expressions. But we're going to multiply in order to get something that is common. So if I multiply 5 by 2, I could get it to be a 10. Now, I have to multiply by 2 on the top and bottom, so I'm really just multiplying by 1. I'm just going to change how it looks so that I have a common denominator and can add. So this is going to become 4 tenths plus 3 tenths, and then we can add our numerators once we have that common denominator. Okay, if they're like this one, I only had to multiply one fraction. A lot of times we might have to multiply 2. So the lowest number that 3 and 4 both go into would be 12. So I have to multiply this fraction by 4 to get 12 on my denominator. I have to multiply this fraction by 3 to get 12 on my denominator. So I'm going to get 9 twelfths plus 8 twelfths. Once I have common denominator, add the numerators. Go ahead and leave it as an improper fraction. Don't change it to a mixed number. This is another scenario where I'm going to have to multiply both. 4 and 6 both go into 12. So I'm going to multiply 6 by 2 to make it be a 12, and 4 by 3. So here I get 9 twelfths plus 2 twelfths is equal to 11 twelfths. Okay, so common denominator, in order to add or subtract, we have to multiply if I don't have a common denominator to get one. Okay, so now when we have variable expressions, we are going to factor the denominator if we can. Now, if we can't, most of the time the common denominator is just multiplying these two together. So I'm going to multiply this one by x minus 3 over x minus 3. And I'm going to multiply this one by x plus 2 over x plus 2. Okay, so here is my problem. I'm going to have x times x minus 3 over x plus 2, x minus 3, plus 2x times x plus 2 over x plus 2, x minus 3. Okay, so now I can add, and I have my denominator. So I've got x plus 2, x minus 3, and then I'm adding these. So I've got x times x minus 3 plus 2x times x plus 2. Let's go ahead and distribute these and combine like terms. So I've got x squared minus 3x plus 2x squared plus 4x over my common denominator. So here I have 3x squared and x. Okay, I could factor out the x just to see if anything else would cancel. Sorry. And I'm just doing that just to see could anything cancel with my denominator. So this or this would be a perfect final answer, okay? Okay, this one, I do have a denominator that would factor. This is difference of squares, so it would factor into x plus 2, x minus 2. Okay, so this actually helps because I already have x minus 2 in both, so I just have to multiply by x plus 2 on this one. And I don't have to multiply this one because it already has the denominator I want. So I'm going to go ahead and distribute already here as well, you guys. So I've got x squared plus 2x over x plus 2, x minus 2. And plus negative, I just changed it to minus, same thing. Okay, so combining, I've got x squared plus 2x minus 8 over x plus 2x minus 2. I'm just going to check, can I factor this? Numbers that multiply to be negative 8 that add up to be 2 would be x plus 4 and x minus 2. And the reason I'm doing that is because now I could cancel my x minus 2's. So I have x plus 4 over x plus 2. Okay, I've got 2 more examples here, you guys. Come on, camera. There we go. All right, so this one I'm going to factor my denominator just to make it easier to see the common denominator. So, okay, so numbers that multiply to be 9 that add up to be negative 6 are negative 3 and negative 3. Okay, come on. Okay, so again, that's going to be my common denominator. So I'm going to multiply this by x minus 3 over x minus 3. So we're going to get x squared minus 3x minus x minus 5 over... Okay, so here's something I want you guys to think about. When you are subtracting, I'm subtracting this whole thing. So this negative really distributes when I'm combining like terms. So it's really like x squared minus 3x minus x minus 5. So because of that, I'm going to get x squared minus 3x minus x plus 5. Okay, so combining like terms, I'm going to get negative 4x. So I'm going to write that over here. So I've got x squared minus 4x plus 5 over x minus 3 times x minus 3. Okay, factor. Numbers that multiply to be 5 that add up to be negative 4. Don't think we have that. 5 and 1. Yeah, okay, so we can leave it just like that. You could also write it like this. Okay. All right, last example here. Again, subtracting, this is difference of squares. Okay, so I have 2x squared minus 30 over x plus 3, x minus 3 minus x plus 5 over x plus 3. So this one I'm going to multiply by x minus 3 to get my common denominator. So I've got 2x squared minus 30 minus, and I'm going to put this in parentheses, I'm going to do this over 1, x plus 5, x minus 3, all over x plus 3, x minus 3. Okay, remember I cannot cancel those. We're going to now, I'm going to multiply and then I'm going to distribute that negative. So that's going to turn into 2x squared minus 30 minus, when I multiply this, I'm going to get x squared. Those add to be 2 and multiply to be negative 15. Okay, distribute the negatives. So now I have 2x squared minus 30 minus x squared minus 2x plus 15. Combine some like terms. So I've got x squared. That takes care of those. Minus 2x. Negative 30 and 15 is negative 15. Okay, this one I think does factor. Numbers that multiply to be negative 15 that add to be 2 would be negative 5, positive 3. And so now I could cancel because I don't have any addition or subtraction between my factors. So x minus 5 over x minus 3 would be our simplified answer. Okay, so big idea there, you guys, with adding subtraction is we have to have a common denominator before we add or subtract. Then when you add or subtract, do it with your numerators, combine like terms. If you can factor and simplify from there, go ahead and do that last step.